Okay, so this is nbody extreme. So my name is Praveen. So what I've done with this project is added a couple of features, mostly in the rendering of the planets, but also a little bit of stuff messing with the gravity a bit, with anti-gravity, which I'll talk about in a second. So we look at these planets. So you'll notice two things. First, that the size of the planets, they're scaling by sinusoids, so that's cool. But the other thing that you'll notice about these planets is that they're rotating actually. So they're rotating, 360 degrees over time, and so that I think makes their motion through space feel a lot more natural. The other thing you might notice is that occasionally one of the planets will change from being rendered as an image to being just a color that's changing over time. That's where we're going to see actually the gravity change effect come in. So this happens randomly, but when a planet goes into that mode, it actually becomes anti-gravity, so it's pushing every other planet away. So that's what we just saw happen. The sun pushed all the other planets away. So you can see in this run it actually happened really early, so they're gone, unfortunately. And this is just another example where that happens. The planets are orbiting and the sun pushes them away once more. So now I've just run it through a couple of the different examples that are provided. This one I think was the antimatter one, and we can see the planets are actually attracted when the one in the center changes to anti-gravity mode, and they keep going away from each other even though it does so again. This one is, I think, the massive squirrel battle, and it's pretty chaotic. We can also see that the squirrels are rotating, and so are the acorns. This one has four identical Earths orbiting around the sun. Pretty straightforward. One of the things you'll notice is that in these sort of orbital systems, the sun is very dominant because it has such a high mass. When one of the planets goes to anti-gravity, it doesn't really affect the other planets. But when the sun goes to anti-gravity, it pushes everything away. This is an example where we see a lot of different Earth planets that are all identical. 100 of them. I think this was the 100 preset. And so it's pretty chaotic, and so you can sort of see that there, with so many planets, you're going to have a lot that are in anti-gravity mode at any given time. Of course, it's hard to really quantify their impact. I think you can see a little bit these two planets pushing each other apart. On the far right side, they were pushing each other apart a little bit, but it's hard to quantify the impact when you have just one planet in anti-gravity. This is the entropy example, entropyuniverse.txt, I think, in the examples folder. And here again, we can see they're all sort of coming in to orbit the sun, coming very close to it, and then the sun can push them all away when it changes to anti-gravity mode, which again happens randomly with a fairly low probability. So this example is called awesome.txt. It's the last example I'm going to go with. Again, one of the examples provided in the project, one of the text files. But this is a very interesting example because it shows one effect that you might not see very often, which is it's actually possible for a planet that's in the mode where it's a circle to actually have the circle size be larger or smaller. So you see some of these planets have larger or smaller circle sizes. And the way that works is, if a planet is in anti-gravity mode, and it's set to anti-gravity mode again, which again there's a very small chance of that happening, if that happens twice in a row, then the planet will stay in anti-gravity mode and it will actually oscillate to an even larger size. So you see some of these circles, some of these planets, because there's so many planets, a few of them are actually set to anti-gravity mode a second time before their first one has expired. And so the result is that these planets start having their size oscillate a lot. So we can observe this dynamic when we have this many planets in what is a fairly stable system here. Because in these two recordings, here the sun actually went into anti-gravity mode, but the planets didn't all escape. And the reason that happened is because their motion was toward the sun at that time. So they didn't actually reach escape velocity, but now the sun went into anti-gravity mode again, and you see their velocity is extremely low, but now they've actually started coalescing back again. So it really depends what the planet's velocity and distance is, whether the anti-gravity mode of the sun in the center will cause them to ultimately escape, as they did just now, or not.